Hello everyone, this is lesson 4.1 ultrasonic sensor. In this lesson I'll go over how the ultrasonic sensor works and how it can apply in many different Arduino applications. Okay, first just a quick demo over here. I have my ultrasonic sensor just right here. There's a piece of tape to just show that there's a distance between here and this book over here. So there's a distance between these two objects. Now before I go over how the physics and how the ultrasonic sensor actually measures the range, I'll just give you a quick demo on how it works. So I have my book. I'm going to stand it up just like this. So with this, I'm going to move it forward and back. If I move it forward and back, I can actually measure the exact centimeters from here to this, from the book to the sensor. Right. So I'm going to run the serial plotter so we can see a physical graph of what's going on. So as you can see, there's a physical graph. I'm going to try my best to make this work. Let's see. As you can see, it's very, very inaccurate, sort of, that you have a lot of outliers, but sometimes if you get it just right, you can get a nice curve when I move forward and back. The reason why we always get some type of zero or all those jumps is because the ultrasonic sensor measures things that are straight upon it. So if, for example, if the book was on an angle like this, the ultrasonic sensor would not read that. As you can see it on the graph, it's not reading anything. It's reading 0. Unless I put it straight upon it like this, this is perpendicular to the ultrasonic sensor. Or would I say parallel? This is parallel to the ultrasonic sensor. Right, when it's parallel, it can send out a pulse and receive that pulse directly into each of its sensors. And the result is you can get the actual distance. One of these sensors sends out a pulse, right, of ultrasonic sound, of course, right? It sends out a pulse and it hits the book. The book then will reflect that sound, and that sound will bounce directly to the other sensor over here. So as you can see, there's two of them. One's sending and one's receiving. So if my book was on an angle like this, I would not receive that pulse. It would send out the pulse, but then it would bounce out that way. Correct? It would not bounce out back directly to the ultrasonic sensor. Same goes for if the book is on a different degrees like this. So if the book is like this, it would send the pulse out like this, but then it would bounce upward like that. If you can see there, it would bounce upward and it would not receive the incoming pulse. So before I jump into the code, I'll post a screenshot of the breadboard diagram just right here. Okay, now that if you have everything wired and properly set up with your Arduino, now let's jump into the code. So the code isn't fairly too hard, it's fairly simple when using the correct library. So in this case, we're going to use the library newping.h. So include new, what's a big N? Newping.h. So now we're going to define our pins. So we're going to define 2 pins and define the max distance that we want our Arduino to calculate. Define trigger underscore pin 12. We're going to connect the trigger pin to pin 12. Define echo pin 11. Define max distance. Let's just put it at 50. So this will be technically 50 centimeters. So now we're going to call this function newping sonar trigger underscore pin. We're just going to pass through our pin values, echo pin, and max underscore distance. So now that's set up, let's also create an integer to store our distance value. Distance, there you go. So now void setup, let's run the serial monitor. Okay, now let's go into our loop. In the old ping libraries, you'd have to convert your values manually by writing a mathematical equation to go from your raw values to centimeters or your raw values to inches. But this library makes it super easy for us because we can just type in mdistance equals sonar.ping_centimeters. So this function will basically calculate our centimeters for us. That's basically the chunk of it. Now I'm just going to print line a few things so that I can view it on my graph. Oops, don't want the space there. Okay, there we go, that's basically it. I'm putting 0 and 50 so I can have the max and min value. So now let's go ahead and run this. So I'm going to run my serial plotter, and there we go. And yay, it's calculating our distances. Let me just put that right there. So it goes up, and the further I get away, it goes lower the further as it goes in. So yeah, this is basically how the ultrasonic sensor works. As you can see, there's a lot of noise, but that's just the nature of how the ultrasonic sensor can read physical values. You can filter out this data with many different filter types, as we learned before in our previous lessons. You can check that back in lesson 2.1 and 2.2, where I used common filtering and differential filtering. Come back for part 2 of this tutorial, where I will use processing application and the ultrasonic sensor together to create an interface. So thank you for listening, and have a good day.